Today we are changing the arms on a Holystone HS720E drone. I picked this thing up very cheap because both of the arms were broken completely off. I did glue them back into place to make sure they were worth trying this on, and it did work. And I'll preface this by saying I didn't look up any guides. I wanted to demonstrate that this is something that anybody can jump into without being afraid of it. I got replacement arms from a seller on eBay. I believe these are 720 arms, not 720E, but they work. Tools you will need is a couple of good surgical trays or anything to hold your screws and parts, broken drone, a soldering iron. Any soldering iron will do. Pointy is better. Solder. I like to have a couple of different pairs of hemostats. I use a short nose blunt setup and a long nose curve setup. Good for fishing out wires, picking up screws, stuff like that. A set of precision screwdrivers, small screwdrivers. Nail clippers, always handy for cutting small wires or stripping wires. An assortment of shrink wrap sizes, side cutters, flashlight, unless your eyesight is impeccable, mine isn't, lighter for shrink wrap. You should always have a sharp knife and not drop it, but I caught it. Sharp knife is essential. And a multimeter that's probably been on since September, but it still works. You need to have that for working on any electronic device. Clearly I have already removed the propellers. Now to start with, there are exposed screws. There's two of them, one on either side of the front near the camera. I started with those. And then there are two screws towards the back. That would be above where the battery port is. Again, keep your screws separate and together. From there, on the rear, there are another two additional screws for each of the covers going above the rear arms. The little landing pads are stuck to these covers. Now, I didn't have to remove the one on the right. I didn't know that at the time I filmed this, but I wanted to see inside anyway. And there's your detent cartridges. Now on the left side cover, whenever you go removing that, there is an antenna glued to the inside of it. So you'll need to be careful of that. I always try to keep my little screws inside pieces like this whenever I can. Now once those two screws on the sides and the two screws from above the battery compartment are loose, the only thing holding the top cover on are some clips along the sides. It requires some exploring with a small flathead to find where those clips are. You just kind of have to poke at the seam until they come loose. Now there are a couple of wires going to some components on that top cover to the board. I need to be careful of those and remove those connections. You can see where the clips are on this top cover. And then for a little surprise, it's a terminal clip from something, don't know what, but it was just rattling around loose inside this drone. Of course it had been flown into a building in a truck. And who knows what else. Get the arms all busted up. So I expect this stuff to be broken, but I couldn't find where it goes. Once the top cover is off, you'll be able to see 4 screws holding down the cage on the front. It's 4 little black screws. This cage up here covers up the detent cartridges for the front arms. Once those 4 screws are loose, you'll need to use a flathead to poke at the little clips on the side. Now these clips are visible, so there's no exploring, you just see them. After you push the clips in, you'll have to give it a little gentle prying. Notice several times I'll be looking at that front camera. The front camera on this thing is kind of angled to the left, just a little bit. I spent a lot of time trying to find out why. I have to chisel off my epoxy. You'll also need to take the power switch off of the front cage to be able to get it off. It's 2 little screws, and then you'll be able to pry it off of the post very gently. Cage is loose, you have access to the detent cartridges. The cartridges on the front are held down with 2 small screws. See, I'm still chiseling at glue there. Then you'll use a small flathead to gently lift the cartridge off of the post and out of the hole. And then the arm's free. The detent cartridges on the back were just held in by the same screws that held the covers on. But you'll be able to just lift those out. In my case, I have to chisel off some more glue. And both of the arms are now loose. A little bit of a close-up where the wiring comes into the body and where it goes to the boards. The motors are all three-phase motors, so there's going to be 3 heavy wires going to a driver board, and then there's 3 or 4 smaller wires that go to an LED board that control the lights on the bottom of the arms. There's going to be another larger wire coming off of the rear arms that we'll talk about later. The way that I chose to go about this is I pulled the arms out a little bit where I had some wire to work with, and then I just put the wires at the bases of the arms. The harness for the rear arms is pretty snug, so it took a little bit of pulling and tugging to get enough wire out there to cut it cleanly. Alright, after getting both of the arms off, I pulled the remainders of the wires up above the body where they're fully exposed. This did require a little bit of tugging and prying. They're pretty snug in some places, but they do pull up. Not really sure what I'm pointing at.
Now the new arms that I got, they are a little bit different. I think that they are 720 arms, not 720E arms, but I can't tell the difference. The motors look the same. They are a slightly different color. There are no silver, or the silver striping is a little bit different on the front arm, but they appear completely compatible, and as I said earlier, in the end, it worked just fine. Let's start mounting the arms to the body. You should go ahead and kind of bend the wires to where they've got a little bit of a hook to them. It helps them feed up through the body up over the circuit board a little bit easier. There's a little hole, everything just kind of pushes through that. The hole in the body is just the right size, which means it is a bit of a chore. You'll need to have something to kind of help poke the wires along, and having that long nose pair of hemostats will help you grab stuff and carefully pull the cables through as needed. Once all the wires are started through and are over the top of the frame, you can start slotting the arm back into place. You'll still have to push some of the wires through behind it, so still requires a little bit of wiggling. Once the arm is in place, you can slip the cartridge back into the hole. You will have to turn it just a little bit to get the holes on the cartridge to sit on their post. It's not difficult to do. And then your arm is in place. Attaching the front arm is exactly the same. We're going to bend the wires slightly to help them feed through the hole in the frame. Going to pull everything up above the circuit board and then carefully slot the arm back into position. Once the arm is slotted into place, the detent cartridge can be reinserted. Again, it will have to be turned slightly by hand for it to set on the post, and this one is secured by 2 screws. Now this is the point where I start to deviate from the normal convention. A lot of people who are looking at needing this repair are apprehensive to do it themselves because they don't want to solder the wires directly to the board. I don't see a problem with doing it, but I also don't see a reason to do it in this case. What I'm going to do is we're going to solder the new wires to the old wires that were left attached to the board, and then we will cover those connections with shrink wrap. Now there are some pros and cons to doing it that way. The biggest benefit in my mind is that there's a much larger margin for error if you're not actually soldering on the board. You're going to have to mess up in a much bigger way to cause permanent damage. The cons are, insignificantly, you will have a little bit more wire that you're going to have to tidy up and hold out of the way whenever you close the case. Now there's plenty of room inside the case, so it's not going to be a problem. More importantly, the wires will now be a different length going to the motors. Anytime you add length to an electrical circuit, it will affect how much current is flowing. But even between the front motors and the rear motors on this drone, the wire lengths are different. I don't think that adding an inch is going to be a considerable factor in how this thing performs. And on top of that, I did have good results. In the end, this thing flew. It did what it was supposed to do without any problems, or I wouldn't be telling you guys that you could do it this way. Now what I started with is trimming all the wires that are still on the board back to about an inch or an inch and a half in length. I don't want any more wire there than what's necessary. This is what I use those nail clippers for. If you have a nice sharp pair of nail clippers, they are very good at cutting these small wires, and sometimes getting a good cut on the insulation to where you can strip them cleanly. Now again, this whole process was very fiddly, very tedious. It took a long time. Basically, I stripped all the wires in advance, and then as it goes, it is attaching light color to light color. Be sure that whenever you start, you put you a little piece of shrink wrap on the wire before you join them, and try to put it as far away from where your joint's going to be as possible. This took the longest part of this repair. I probably spent nearly 2.5 hours, maybe upwards of 3 hours, replacing both of the arms on this drone, and at least an hour and a half of it was spent doing the wiring, making these connections, soldering them together. I had to go back and redo a couple of them just to make them better. It had been a while since I've soldered in this fashion, so it took a couple of attempts to get back into the groove of things. But again, very tedious, very monotonous, very time consuming. This part here is what I was talking about. Whenever you're soldering on the board, it's easy to get splashes and solder to bridge connections that you don't want connected. Even then, a little glob of solder fell off of my connection and went down and connected two different connection points. I had to scrape that off. Working with the wires itself, I was careless and I worked directly over the board. But one of the benefits of working with the wires is that you can move that out from over the board where I should have been doing it, and then if pieces of solder do fall, it doesn't hurt anything. And now once your connection is complete, you can slide your shrink wrap up over the joint and then apply a little heat, because that's how shrink wrap works. And then that circuit is complete. And then it's just repeat it about 400 more times. Okay, whenever I started this video, I wanted it to be an example of the entire process from beginning to end, so that you guys could really see what you're getting into. I didn't cut out any significant steps, so very little cutting. This part though, I am speeding up. This total section is probably about an hour in time spent, because it is the same process over and over and over again. You are attaching like color wire to like color wire. You're making a solder point, you're covering it with shrink wrap, and then you're sealing the connection over and over again. It's the same each time. Now the rear arm has one more wire than the front arm. This wire is thicker, it's a little more rigid, the sheathing is slightly different, and it is black, just like the other wire for the drive motor. It does stand out a little bit, so you should be able to pick it out without too much trouble. This wire is a coaxial cable. I'm not 100% certain on this, but I believe that it is for the antenna. Now what I ended up doing here is I stripped the sheathing off of the outside, the shielding, and then I moved that back and then stripped the inner cable. Okay, and now looking at the shielded cable on the drone itself, on the board, I couldn't tell if they were using the shielding as part of a circuit or if it was being used strictly as shielding. There were two contact points on the board that it seemed like the wire was going to. So basically what I'm doing here is I'm checking resistance between the shielding and the core, and between those 2 points on the board, and between those 2 points and the shielding itself. As it turns out, it seems like the core wire goes to both of those points and the shielding is isolated. But the shielding could also be connected some other way, and maybe I didn't see it. So I proceeded as if that shielding was part of a separate circuit. Whenever I connected the wires, I soldered the core together, and then I soldered the shielding together, and then covered the whole thing up in shrink wrap. This should maintain any circuit that the shielding may have been a part of whenever we started. Now something I want to point out is that shielded wire, getting the outside insulation off is pretty easy. It's like stripping any other wire. At that point you'll be able to push the shielding back and be able to twist it together from there, or what I did was I widened a hole in the base, or close to where I stripped it back from, and pulled that core wire through. That's how I got enough of the shielding to where I could solder it together. The core wire though is very delicate, and I accidentally cut it off several times just trying to strip it down. You have to be very careful with it. It's easy to accidentally cut, and if you cut too much of it off, you start running out of wire that you can use. Basically what I did is I used nail clippers to score it slightly, and then I heated it up with a lighter, and that made it easy enough to pull apart with my fingernails. I think that's the best way to go about it. And of course, after getting the core soldered together and the shielding soldered together, I covered the entire connection up with a larger piece of shrink wrap where it's nice and isolated and sealed up. Now, anytime you make a repair like this, you should always go back and exercise the arms and make sure that all the wires are pulling and moving exactly the way they're supposed to. You don't want to get this thing all put back together and then go to unfold it and then learn that one of the wires or arms or cables is in a bind. And also, as explained earlier, doing it this way does leave additional wiring that you will have to tidy up whenever you go to close things up. That's why it's important to make sure that you don't leave any more wire in the body than what you need to make the connections comfortably. I can't remember if I mentioned this towards the beginning of the video. I spent some time playing with the front camera because it seems like it's pointed off to the left a little bit. Ultimately, I couldn't find a reason. Reassembly is exactly the opposite of disassembly, other than you're just kind of making sure that those wires stay out of the way. That front cage goes on first, and then you'll place the power switch back in position. And then there's 2 screws to hold the power switch down and 2 screws on either side of the cage. And mounting the top is, again, exactly the opposite of removal. You'll make sure that your 2 connections are in place first, and then the top simply snaps into position. There's 2 screws above the battery compartment, and then a screw on either side closer to the nose. And now you have a complete repaired drone. With any repair, it's always a good idea after you're done, throw a battery in it and just make sure that it turns on. And we have power. So now we'll need to throw the props back on, take it outside, see if it flies. Okay, now we come out and see if it flies. It's a little breezy, shouldn't be too big a deal. Out. I just went over all the screws, they're all nice and tight. Alright, next. Click, click, click. Whoops. Forgot the important part. My Xeno just plugs into the camera. I don't have to connect to Wi-Fi. Wi-Fi. Connected. Okay, let's go back to this. It says we got it. Now, since I just had the thing all apart, we are going to do all of the calibrations. Okay, and then head up. Okay. Let's do the gyro. Hey. Gyro is done. I'm going to go ahead and change this to 1080-60 so it matches all the rest of the footage I'm doing. There's just a pretty good wind coming from this direction. Let's go fight with that a little bit. Let's get it up. Look like that left side wants to jump a little bit. I don't think it likes this white rock. Let's move it over the grass. A little bit more texture. Decided to take itself up there. Don't care much for that. Let's just try flying around a little bit. That picture's crooked. Don't want to get any higher than that. Okay. It'll be higher that way. Okay. Alright. Okay. It's good. See from the dust, it's actually, you know, about 5 or 6 mile an hour wind. It doesn't like that. I'm making it bounce, just try to blow that dust up a little bit. Apparently, if you get it that close to the ground, the sensor can kind of hang on to how far it is, how high off the dirt it is. Bonk. Okay. Well, the ghetto repair, it definitely got it back up in the air. It's flying mostly evenly. I say it's a success. Alright. Well, that's that. It is now a $150 HS720E